So we've been doing lots of work on patterns and how a pattern goes on, how to write a rule for a pattern. And there are certain things that you know, like if a pattern goes up in twos, the rule will start with 2n, right? That's the bit that goes up, right? And if you know a rule is like 3n minus 2, what does the pattern? Does it go up or down? Okay? Up by 3. Good. So 3n minus 2 would go up in threes. All right. The minus 2 is not, it doesn't go down because of the minus 2. That's what you have to do after you've figured out how many lots of 3 you need. All right. Okay. Then we went to a stage where we were talking about, well, is a number in the pattern or not? So we did some work on that, and we used algebra tiles. So there's that link to a couple of different algebra tiles. Do you want to be ready? I mean, it's not lunchtime now, so you know. So we looked at, is 8 in the pattern or not? So we could do that. Is the rule ever equal to 8? And how do we know if a number will be in the pattern or not? Rocco, what do you think?
If it's like 8 and minus 2, then like 445 wouldn't be in there.
But how could I, what maths could I do to check? How would I know for sure? What would I do? Yeah, we could just keep adding on 8 in that case, or so hang on, let me just maybe I'm just going to add a bit in here just so you can say what you want to say. So you said if you've got something like Tn is 8n, let's say minus 1, and you were saying is 455 in the pattern, right? So you would say, oh, we could start with 7 because that's the first term, yeah? 8 minus 1 is 7. Then we go up and we go 7 plus 8 is 15, plus 8 is 23, plus 8 is 31, and so on. And we'd have to get all the way up to whether 455 is in there or not. It's a long way, but yeah. Des, what would you say? What's the other method?
So you start with the 8 subtract 1, you have that number. And so you're doing 455. Wait, you've got to write, okay, you've already written that. So, but you've got to write, does Tn...
so does 8n minus 1 equal
455.
Good. That's the statement, isn't it? So that's what we're trying to find. And if we solve that, what do we know about n? N has to be G. But what does it have to be? We need to find n. And once we've found n, if it is in the pattern, what do we know about n, Ryan?
N will be the term that 455
Yeah, and so n has to be?
whole number.
Whole number. That Des couldn't resist anymore. N would have to be a whole number. If you find a decimal, it's not in it, right? So you can always figure out what n will be, but whether it's a decimal or a whole number or not. So let's just check. If we had to do 8n minus 1 is 455, right? We could set up algebra tiles. Remember, we have the page split, and we could have 455 units on this side, and then we could have 1, 2, 3, 4 n's, and then a minus 1 on that side. And both methods, whether it's algebra tiles or algebra, what's the first thing you would do, Des?
Wouldn't it be 8n?
Sorry, yeah. I don't know why I'm thinking. 8 n's, yeah. There'd definitely be 8 n's. You're right there. Logan? Okay.
Did you say what would be the first?
Yeah, what would be the first step?
What's the word? You would add the one that's on.
So, like you've done before, we've got other options there. Logan, stay with us then. So if this is the rule that makes the set of numbers, is this one in? So imagine we put a box around that, okay? We said what subtract 1 would make 455. Well, we can do that by adding the 1 back on and saying that, well, before we subtract the 1, we have 456. And then what's left? So the box would be 456 subtract 1 equals 455. So if we add the 1 back on, we're left with just the 456 is the 8n, yeah? So n lots of 8 makes 456, and final step, Max, is to Emma? Divide it by 8. So in the algebra tiles, look, you would have added 1, put a positive 1, same on that side. Then we have to do the division, don't we? So 456 shared between all the n's. So we have to do n is 456 shared between the 8 n's we've got. Can you just do that for me? You got a calculator? Yeah? Okay?
57.
N is 57, you think? Yeah? Can we all confirm? Get your calculator out and confirm? Yeah? So what does that mean then?
It's that 455.
So 400, oh, my computer stopped working. 455 is the 57th number in the pattern. So if I were to carry on like this, 7, 15, 23, 31, 39, 47, 55, so on, I'd have to get all the way. So that's the first term, that's the second, the third, the fourth, the fifth, the sixth, the seventh number. I would have to go all the way up to the 57th number, and I'd see that was 455. Logan, what would the 56th number in the pattern be? Because if it's 8n, we know it's plus 8 every time. So if actually to go that way, it's plus 8. If I want to go back to the previous one, I have to 447. See, he does get it. We have to subtract 8, look. All right, so that's where we've been at. So we're just going to practice a little bit of maths before I let you get on. So, do you see how this relates to it now? So the starfish can relate to the n. Good. All right, so we could put an n instead. All right, it's not a very good colour, is it? It doesn't show up. All right, let's go for yellow. N. So 4 plus something makes 11. Then the n must be?
7.
7. Good. Got that? Tristan. 24 minus 4 must be?
11. Wait, no. 21.
N. Therefore, n must be? 21. The yellow works here, but not there. And I'm not going to change. Just do it quickly. What do we think, Heidi, because you've been away of it, if I do 5 multiplied by something, so I'm going to call that the n must therefore be equal to? God, her voice throws, sounds like a boy's, everything, you know. Do you agree with him? Yeah? 4. Okay. So n minus 4 has to equal 9. What do you think, Simone? Good. Lots of people fall for that one and say 5. Because they just look at 9 and 4 and think 5. 5, 4, 9. It goes together. It's a common mistake, you know. Kieran then. So 5 plus n, right, is the same thing as 14 minus 6. So we have to work out 14 minus 6 is 8. So 5 plus n must be 3. There you go. Good. Reese, welcome back. 6 times 2 is the same as 3 times something. We'll call it n. N has to be 4. Good. Yeah. All got 4? Because 6 times 2 is 12 and 3 times 4 also makes 12. Okay. Jackson, 5 plus 4 is n. Therefore, 3 times n should be... You're close. You did the first step. That's 9. N is 9, but I'm asking you for 3 lots of n, which is... Give him a chance. He'll do it.
He said it.
Did he what? No. Go on then, Keen.
27.
27? Yeah?
N is 27?
No, n is not 27. Yeah, 5 plus 4 is the same thing as n, and I actually want 3 lots of whatever n is. So that has to equal, because it's 3 lots of, you've already decided it's 9. Yeah? Finally, what do you think, Tristan? N subtract 6 is 14, therefore 4 lots of n must be...
And 4 times 20 is 80.
Good, 80. Yeah? Getting the idea? Just using the unknown, that's all it is. Right. This is just, yeah, algebra. So what you're going to be doing is, you're going to be doing this exercise here. All right, practice 6. All right, so there's 2 parts that I've started with. First of all, determine which solution is correct. Then solve them. Now, before you get on, just in case you need it, on my notes, and I put this on Teams just in case you want it at home as well, I've put an example here. So this is the first one. So just to show you, look, if x plus 11 has to be 25, which one is correct? Is x 14 or is x 36? So I've said x should represent the number in the pattern. So we've got that, but that's not that important. But if we say, right, if x is 14, then 14 plus 11 should equal 25. It does. That's a correct statement. So I'm kind of thinking x should be 14. But I'm just going to check the other one. If x is 36, then 36 plus 11 should equal 25. That's not true. Okay? So unhappy face. Therefore, x must equal 14. Yeah?
Yeah, if you do 36 minus 11 is 25. Yeah, but also,
Yes, but that's the trick, isn't it?
But, yeah, because if you start with a bigger number and you add something onto that number, then it's always going to be bigger.
Yeah. Are you all right, Ryan? You're throwing stuff around my room on my video. I can't edit that out, by the way. Sorry. Emma. No. Right. But what I do want to see. So these are notes. So instead of you making these notes, I've put this document, Ryan, are you with me? Because you and Max are making eyes at each other. Yeah, not concentrating. And this is going to be important stuff, right? Just saying, guys, on Teams, you've seen on Teams already that I put notes, didn't I? All right. So under the Teams notes for today, right? Well, mine's not refreshed yet, so it'll be under here. Max has already said thank you. All right. So notes will be there, and also actually, is it on class? There's actually in class notes. All right. So I've done that there. So this helps you if you want to study. But what I would like to see, guys, when you do that first question, is I would like to see at least you do the check of the 2 things. Yeah? So check both even if you think it's really easy and you know which one it is. Show that one of them is and one of them isn't. Is that clear? Yeah. All right, now before you move on, let me just go for the next one, okay, which is solve the equation, all right? So q plus 4 is 19, simple one. So this time you're not being given the solution. Makai, you with me? You staying with me, yeah? So I'm just, what value of q would make the statement correct? All right, so it's probably quite obvious to you guys that 15 plus 4 makes 19, but I've shown you the method so that you can apply it to harder ones. So we're going to do 19, just like we were just doing, 19 minus the 4 makes the 15. So q equals 15. Now I've shown it here, look, in algebra. So this is what I would expect to see in your book if you want to do it algebraically like that. So you write the question out, you write down what you do. So I've subtracted the 4, look. I don't want to see it like this because that's words. If I do it in algebra, I'm going to show that on both sides I'm subtracting 4, right? And that leaves me with the plus 4 and the minus 4 cancel out, and I get q must equal 15, the same answer. Now, just in case you want to use the algebra tiles, I've also shown you, look, how would it look with the algebra tiles? So we have the q, the plus 4, on this side is the 19, yeah, the equal sign here. How would you remove the plus 4? Well, again, I have shown it, so these are in the notes. You've got to put on the negative 4 that gets rid of the positive 4. You do it on the other side, and these ones cancel each other out. Those ones cancel each other out. So you're left with just q is equal to 15, because there's 15 there now, all right? So if you want to use the algebra tiles, that's what you can do, all right? So your job now is to go through question 1, question 2, try and get as much of, and question 3, all right, as you can. Question 1 and 2 should be good. Show you working, practice your communication. If you have a specific question I can help you with, I'll help. I don't get anything, because you definitely get something. Just think, where am I at? Where do I need help? So this exercise is, like I said, page 108. All right, that's your job now. Get on with it. So to work the question out for question 2, the q plus 4 is 19. I would expect to at least see, if I get rid of all my orange, something like this, yeah? Because what you've shown by writing it like this is that you've got q plus 4. What was q before I added 4? Now, instead of writing that, you can just put the subtract 4 on both sides, yeah? And then you end up with just the q equals 15. So that is 2a done. I don't need any more than that. But, like I was just saying to one of your colleagues, all right, what I don't want to see, are you listening? What I don't want to see is this. This is a big no-no. Q plus 4 equals 19 minus 4 equals 15.
You have to put it on a line below.
Right? This is an incorrect use of the statement, because that is equal to 15, but that is not equal to 15. So you can't just write. So this is a big no-no. I'd be very unhappy if I see that in your book. I want to see this, laying it out. Okay? Yeah, I'd be a bit, yeah, definitely.